The modern Formula One grid operates as an environment of extreme financial restriction, governed by the mandatory FIA cost cap. This regulatory limit contrasts sharply with the physical assets on the track. Manufacturing a single current spec Formula One prototype costs upward of $20 million. The Mercedes-AMG F1 team's 2024 results highlight a growing financial anomaly. Their revenue grew 16% over the previous year, reaching a record £636 million. Despite finishing fourth in the Constructors' Championship, Mercedes reported £160 million in operating profit, or EBIT, showing a massive return on investment regardless of their track position. High track performance is decoupled from financial returns. The sports business model now operates independently of lap times. The 2026 FIA Formula One financial regulations enforce this new economic framework, acting as the definitive blueprint for team spending. Article 4 of these regulations mandates strict compliance with a $135 million ceiling, represented here as a hard mathematical limit pressing down on rising engineering costs. To understand how teams maintain competitiveness under this restriction, we must deconstruct the $20 million car, component by component. By mapping these physical parts against the FIA ledger, we can see how F1 transitioned from a blank check arms race into a ruthless optimization problem. Under this system, every pound of carbon fiber is a zero-sum financial trade-off. We begin with the largest single expense on the grid, the 1.6-liter V6 turbo hybrid power unit. A customer supply deal for these units costs roughly €15 million per season, putting the total valuation of the engine program over $16 million. This is a significant jump from the previous era. Older naturally aspirated V10 engines cost only about $2 million per unit. Higher reliability requirements drive this cost higher. Regulations now restrict teams to using just 3 or 4 power units per season, a massive reduction from the dozens used in decades past. The price reflects immense engineering complexity, specifically the integration of the internal combustion engine with the MGU-K and MGU-H energy recovery systems. This mandatory baseline cost devours a huge portion of a team's available resources before the chassis is even built. The car's structural core is the carbon fiber monocoque, which also serves as the driver's survival cell. Fabricating this 35-kilogram structure requires between $1 and $2 million in bespoke manufacturing and composite materials. Safety mandates increase the bill further. For instance, the titanium halo is designed to withstand 100 kilonewtons of force. Aerodynamic surfaces follow the same trend. A single front wing assembly costs over £100,000 to produce. The floor, which generates up to 60% of the car's downforce, costs another £100,000 per unit due to its complex geometry. These costs stem from low-volume, race-by-race iterations. Standard manufacturing economies of scale do not exist in F1 aerodynamics. To complete the $20 million bill, we add high-end consumables, a full set of carbon brakes at $66,000, and a bespoke steering wheel costing up to $100,000. This chart shows the total operational ceiling. Once adjusted for inflation and the 24-race calendar, teams must manage their entire performance operation within roughly $142 million. Article 5 of the regulations defines exclusions. Large expenses like driver salaries and marketing are removed from this total to isolate the strict performance budget. This creates an R&D squeeze. After subtracting fixed costs, including car manufacturing, global freight, and staff salaries, the capped budget begins to disappear. The final calculation is striking. From the original $142 million budget, the actual capital available for in-season aerodynamic upgrades is limited to roughly $12 million. In this environment, physical crash damage is the ultimate threat to a team's development. Red Bull Racing's 2024 season serves as a case study, with the team incurring an estimated $3 million in cumulative crash damage during the first half of the year. This creates an accounting trap. Because replacement parts fall under the cost cap, the $3 million required for repairs diverts funds directly from the $12 million R&D pool. This 25% reduction in the development budget forces teams to cancel planned aerodynamic upgrades and wind tunnel testing. Beyond the immediate loss of points, a major crash creates a deficit in the car's aerodynamic evolution that persists for the rest of the year. This efficient era is a departure from the past, when teams could spend $400 million annually to brute force performance through endless design cycles. By capping development, the FIA severed the link between unlimited corporate spending and championship success. This structural shift ensures that commercial growth translates into profit. The Mercedes team's £160 million EBIT is the direct result of this capped spending model. We see the weight of this new reality in General Motors' entry. Cadillac agreed to pay a $450 million anti-dilution fee, more than double the previous requirement, simply to secure a spot on the 2026 grid. Corporations are paying $500 million for an entry because the cost cap provides a path to profitability, turning teams into self-sustaining franchises rather than financial black holes. The championship now hinges on a financial optimization equation. The team that extracts the most lap time per dollar spent wins.